They attend EPA scientific webinars and so events like that. So they're very up on what's going on in the literature and activities. They are motivated to build their own hardware. So under the goals and needs area, we see that. And they have a lot of questions. They want to know, how can I trust the data? How many sensors are there? Where are they located? And when you do this kind of persona work, you really need to understand what are the workflows and the applications and the environment that these people are working in. So in this case, this is a user who may have a very high-end expectation about quality of experience. They use Apple devices. They buy Arc'teryx clothing. They buy North Face. They are really looking to create something. They want something created for them that can monitor their air quality in the technologies and the environments that they're used to. They want it to be simple. They want it to be beautiful, and they want it to be easy to use, and they want it to be trustworthy. So if you look at zooming in some of these attributes, we looked at the frustrations as a real driver of what it was we needed to think about when we started to think about our solution design. So really, we first start with the problem, figure out, is that problem real and interesting, and is there enough critical mass about that problem with people who have that problem? And then we decided, okay, let's take a look at what we can do to design for that. So the design challenges from a UX perspective, certainly presentation. When you look at the software stack, the presentation layer at the top, what does the data look like when it gets presented to the user? Excuse me. How does it get presented? For a scientist, they may be expecting an Excel sheet, versus a citizen scientist, they maybe expect something that's at a glance or easy to use, that is not as scientific looking. And also, they're expecting a consumer quality experience. So remember that persona definition where they have an affiliation or an interest in, they use Apple devices, for example. They have an expectation. And when we deployed our go-to-market on Apple iOS device, that really sets an expectation for the quality of experience. So the underlying platform in this case sets an expectation because it has its own UI framework and a kind of interaction language that is set by the platform. And so the interaction model, not the visual part of it, not the presentation. Now we're digging a little bit deeper into the stack, going down into the services and the data. We're looking at what are the workflows, and what does the data need to be mapped into an experience that the user can interact with and value. So in case of looking at sensors across geographies, when we added mapping, thinking about how to create a great mapping experience with the gestures and the interactions that are used on the platform. Those are all part of the interaction model. And also at that time, whenever you're doing that kind of work, you have to be cognizant of performance, because if the performance is affected, it can really impact your perception of quality of the user experience. So we had some, somebody's got a noise happening. Can you put your mute on? Thank you. So the interaction model and the performance have to be appropriate for what you need in the product. So our original mapping design when we first launched it was poor. I'll show you an example of that. And so you really need to make sure that you set a standard for that, and it has to be appropriate for what the user expects. So we're going to do a little primer. For those of you who know this already, you don't have to necessarily lean in, but for people who are on the call who don't think about this every day, we're going to look at a little bit of a primer on interaction design, a toolkit for what does it mean to design user experience when you're dealing with lots of things, lots of entities, okay? In this case, we're talking about entities of sensors, lots of sensors all over the world, but it could be other things. So just to start, when you're designing a solution where you're displaying only a few items, you can basically put it on the screen. You may have some sort of index, and you really have only the one entity. And this is a good example of what one entity might look like. But when you have lists of many things, you end up having to use these techniques that we all know. So you may use scrolling. So if you have 1,500 things, you might need to use scrolling to be able to let the user look through the collection. You might use pagination. So that same page needs to break up the data into a number of pages that the user uses. Pagination UI component to navigate. Now, there's also infinite scrolling. For those of you who use like Twitter on an iPad, for example, infinite scrolling is being able to just continuously scroll. You never reach the bottom. I always thought it was weird when I first experienced it, but some interaction model works well. And then we started, you have to start thinking about clustering. So clustering is when you have a lot of entities and you can't necessarily show them all to the user, and you have to come up with a really intelligent way to cluster the data and display it at the right level of abstraction. So this example is, there are like lots of dresses in various colors, and you don't necessarily have to show every single dress in every single color. You can do an abstraction and a kind of summary, and that's what we call a cluster. And you'll see that later on when we talk about how we solved that challenge in Local Haze, because we had a problem with our mapping. The data was not being reflected well and accurately, and people were complaining, and we had to come up with a clustering set of heuristics. So beyond clustering, you can do keyword search. You can actually let the user type in a keyword, and hopefully your taxonomy is well done so that you can actually find things. But you have to ask yourself, well, what happens when search fails to return a manageable number of results? It's just too overwhelming number of results in what gets returned. And so you want to help the user search more precisely. And so you might use faceted search. So on the left here, you can see these are the facets resulted in a search for unicycles. The facets are really category tags of the search results. And so they help the user navigate the result space. You should be familiar with that if you've done searches on eBay, for example. For those of you that are more towards software engineering, you can see that you could also use a query language. So you can see query languages, they're used in Jira and other tools. And that is typically, not consumer quality interaction, but that it is useful. So you can see that some tools like Jira allow you to actually write the query to be able to do your searching, and that works for some users. But if the user can't search precisely enough, in other words, the query doesn't work and you want to use another technique, you might try to organize the results. And one way to organize is what we call progressive disclosure. So here's a progressive disclosure of unicycles in a search result, where they're being disclosed in a kind of way that shows you a sample and then a link to more details, but that's progressive. It doesn't show you all the results at once. It sort of chooses which ones are more relevant to show first, and then rates appropriately the other results. Now you can also sort by relevance. So here's an example where you search for coffee places in downtown, and you can see that there's a matching based on your own user behavior. Okay, so that's an example of relevance calculation. There's another example. You can see your browsing history, for example, might be used to determine what gets displayed to you and the order of the results. So these are all different techniques that are a part of how you might do interaction design when you have lots of entities. So now that we've gone through that as our primer, we're going to say, okay, now let's take a look at what it takes to design an iOS application with a variety of interactions for a great experience. Because we now, based on what we've seen, we have a toolkit of interactions for dealing with objects at scale, lots of scale in entities. When I say scale, for those of you that don't know that term, I mean many or thousands, hundreds of thousands, even millions or tens of millions of entities. With Local Haze, we're dealing with 30,000. So that's like multiple tens of thousands. And that's a really good scale and a lot of challenge in terms of design. So what we did first with Local Haze is we applied the infinite scrolling list. So if you look here, you'll see this is what Local Haze looks like when you have an infinite scrolling list of sensors. And you can see the list goes on and on and on. And users said, well, I'm having trouble finding my sensor. Or we said, okay, to help manage that infinite scrolling, that was a good thing to start with when there weren't necessarily as many sensors as there are now. We said, okay, we'll start adding some features into the interaction to help manage that infinite scrolling list problem. So we added filtering. So you can see, the user can enter a keyword and then get the list filtered with the sensors that have a correlation to that keyword. And that helped. And there was also expectation because, again, the native platform has search sort of expected. So if you use the pull down gesture on iOS, the user often expects to see a search entry there. So that worked out really well. We had users tell us then, I want to be able to sort of pin my favorite sensor so that I don't always have to be going to look for it. So we call this relevancy. We said, all right, after we've done the filtering, let's try that. So you can see we were rolling out these features kind of as users were asking for them and as we were seeing, you know, people complaining about things. And so we said, all right, let's do this feature. Here's an example of the downtown Toronto sensor. It's actually the one that I showed you. This is an AirNow, a government sensor, so well calibrated, high quality data. You can actually see in the reading the AQI value is good, but the confidence is it's okay. It's not 100%. And in this case, if you set the icon here, you can actually pin that sensor, excuse me, to the top of your list. So it's the top of your sensors list. In the main navigation, you have list of sensors, which are based on your physical location of the device, a mapping view, and then other associated menu items for looking at number of sensors or purchasing. So we added a map view after people said we want to be able to see our sensors, you know, the geography of our sensors. And that was a big feature, very, very difficult to get right. You can see on the left is what the maps, when we first launched that feature, this is what the map looked like without clustering. So not very nice to look at. We did not really know that it was going to be so bad. And people complained, and we said, okay, we had a smaller audience at the time, and we said, okay, let's now figure out what does it mean to design those clustering algorithms and figure out how to do the heuristics. So on the right, you can see a more recent version of the map where we have figured out how to do the clustering that's appropriate for any level of abstraction. So, and remember, at any time, the user can be using the pinch and zoom gesture to navigate the map. So they can pinch, zoom, and go in, and now you have to recalculate for that particular area of summary, what is the appropriate view. And what we did was we came up with a visual language to indicate for a particular set of sensors at that level of scale, this is the number that are good, these are the ones that are not so good, and these are the bad. So we try to reflect that in the color of the ring with the number. People did have some confusion asking us, like, what does the number mean? But the number is the tally of sensors in that location at that level of scale. So the presentation challenges are, you know, you have to be able to visualize what does it mean to see 12 sensors at this level of scale, 41 sensors, and, you know, really in different parts of the world, the quality of the air is quite variable. And, you know, what does it mean for someone to be able to look at the map and say, okay, there's 41 sensors there. Now let me drill down or let me tap and see the detailed sensor. So the interaction kind of changes between navigating via the map versus the tap and then being able to drill down into the details. Very interesting, very demanding in terms of the OS, you know, be having to present that in real time and create a good user experience consistently. On the left, you can see that here's a zoom out scale. So that's North and South America. There's a little bit of Greenland up there. So you can see the view at the very high level scale. And then you zoom in to California, you can see that there's a lot of sensors in this area. And especially since the occurrence of wildfires in the last few years, we've been seeing many, many thousands of sensors coming online quickly. And so you see the readings change a lot, you know, and so being able to now zoom in to Los Angeles there at this level of scale, this is all done with a single gesture. So a pinch and a pull and a zoom in, and to be able to see the sensors that are at that location. And then at any point you could tap and then get the list and scroll it and then drill down into a detailed sensor. So there's a natural progression of zooming from the map view on the left, tapping on a list, seeing the list of sensors, choosing one, and then drill down. So there's a kind of natural narrative to the interaction. And that was very interesting to design, very interesting to design the visual design. So you can see some of these readings are a little bit faded, you know, so they show a little bit of question, you know, a little bit suspect in the data because it's not quite 100% not quite confident. And confidence is a set of heuristics, part of which includes recency of the data. So how recent is the data, i.e. freshness? How well does it correlate to sensors that are in the area? How long, if the sensor data is really old, then that becomes, it's more suspect, right? That's an example. So that's why when we look at the sensor details, we are showing with as much transparency everything about the sensor. This is the purple air sensor I showed you earlier. It has dual laser measurements. So it's reporting 2 measures for every single one category of PM classification. So you have PM1, you have 2 lasers, and you're looking at how well does the laser reading correlate to each other. And that is part of what it's used to calculate the confidence. So, our users want to know as much data that is being reported by the sensor with as much transparency as possible, including its position, its any of the data that's coming in from the device, the origin of this data, and the last updated. We call this a timestamp. That's a strong indication of data freshness. So when we look at the interaction model, here we go. We're zooming out. You can see it's in real time. You zoom in. You can see the sensors, a lot of sensors. These are mostly sensor.community sensors in Europe. Drilling in, looking at the sensor, and looking at it in detail. Very clean navigation, and moving from scaling way, way out, scaling in, and then drilling down. So we talked about scale in terms of geography and number of entities, many tens of thousands. We're going to talk about scale in time, or temporal scale, we call it sometimes. So we found that users wanted to be notified about changes to the air quality at a specific location. Hey, I'm in Mountain View and there are wildfires in Northern California. I want to know when my sensor is reporting poor air, that kind of use case. We said, all right, let's go look at how often the sensors are reporting. So the purple air sensors report data every 2 minutes. So that cadence is pretty quick, but other sensors report the AQI data at different intervals. And so that 2-minute interval was interesting because we said, all right, we have to figure out the right heuristics, because you don't want to constantly be notifying the user with too many notifications. And at the same time, on the right, I just want to show you, this is the visual language that we came up with for Local Haze. It has very clean, identifiable design, and it maps that US AQI index into a somewhat, just a smaller, more compact version. It has 5 categories instead of 6. This is the really, really poor air here. You do not want to be in a place with air with this guy on your map. And the confidence ratings that are badges that are applied to the icon. So on the left is the UI. We wanted a really simple interaction. So in order to turn on the notification feature, you just tap the bell. And as soon as you do, now you are getting notifications about any change to the air quality. We're still working on this feature. It is far from finished, but it is the first representation of the feature. It's also a subscription. So it's a subscription model. So the app is free, except now if you want to get these notifications, you have to pay a subscription fee. And when you can see the way it works is here, the notifications are coming in, and you can see that they can sometimes pile up because there's too many notifications. So this was a problem. People complained about the cadence, and that's a form of temporal scale where you have to really understand what is the appropriate type of experience. And for the purple air sensor, reading data every 2 minutes, that cadence can be too fast. We had a lot of users complain, especially those out in Northern California where they're in wildfire areas. When there's an AQI reading near the boundary of the index range, it was oscillating back and forth across the boundary and throwing a lot of notifications. So someone actually sent me their screen grab from Redwood Grove. You can see it on the right. Sensor is throwing a notification every minute or 2. That's far too frequent. And this oscillation is like too jarring for users. They don't want that. So we're working on trying to smooth that oscillation so that you only get the most important kind of notifications. We got lots of feedback. We did a beta release with 10 users. They complained first about the notifications. So we've been working on our algorithms to smooth that out and get that notification cadence appropriate, but it's ongoing. And that's one thing I want to say about doing these kind of products is you don't release it and then it's done. It's continually working on improvements. It's very different than doing a movie, for example, when it gets released, or you have the opportunity to listen to your users and listen to what their concerns are, and then really work to make adaptations to the design to improve the experience for them. And that is what we do. We are thinking hard about what is the right way to notify for a specific sensor. How do we filter out too frequent notifications? Anybody who works on user experiences with notifications knows that false positives are the worst kinds of notifications. Users begin to eventually tune you out. And so we want to be able to really figure out like what's the right notification and what's the right sort of way to design it so that it either remains persistent or it's ephemeral. When I say ephemeral, it means it fades away over time. And so we've been experimenting with those kind of options. You have the notification curtain, which is part of the iOS framework. So the notifications come to the curtain and then they kind of cascade down the front of the screen. That is part of the way that iOS works. So we're working on trying to improve that to get notifications exactly as close to perfect as we can for our users. So overall, what are some of the lessons that I've learned and what I can share with you about designing user experiences for monitoring air? The first one is just understand the user's needs. Go back to that persona framework. And if you want that framework, I can give it to you on the slides. It's useful to look at as an example, although everybody has their own persona framework. And also their user journey. So what is the path to value and what are the touch points along the way? I really strongly recommend that you do user journeys per persona. You don't conflate lots of personas in a journey because then you don't end up with the crisp experience that I think users are demanding, in particular consumers who have expectations, for example, an iOS quality experience expectation. So this is the journey map for Local Haze. This is the one that we did after we launched the subscription service. And so for the persona, the air quality enthusiasts that I showed you before, we are looking at what happens when the user goes through discovery. That's before they actually start using your product. They may get a search result, they may get a link from someone on social media, and then they land at the App Store. The App Store is a really critical part of the journey. If the App Store content and the experience does not sell the download, your user is not going to download the app and your downstream metrics will fail. Once the user launches the app the first time, how do you onboard them and welcome them and make them feel like, oh, I'm really excited about this, and make them glad to actually have downloaded the app. And then for engagement, we wanted users to be like browsing sensors lists and drilling down and looking at things and maybe using the map and then being able to favorite their sensors. We wanted to see that kind of engagement with the sensor data. And then eventually we would like it to lead to a subscription purchase. So there is a purchase. You can actually use the app for free. You don't have to purchase anything, but there is a purchase part of the journey. And then evangelism is sharing out. We have a feature for sharing maps. People can share a map anywhere in the world and show what the air quality is. And so we're watching those with all of the metrics associated with each part of the journey: number of installations, number of downloads, number of favorites, for example, is a good one, and the number of shared maps. So, this is not the only way to do journey mapping, but it is a way to look at the phases of the journey, the touch points of the journey, and the interactions that enable you to get from point to point in the journey, excuse me, and then the metrics of each step of the journey. Our journey for onboarding originally needed some work because people didn't really understand what the visual representation was. They didn't understand what that badge meant. And they needed a little bit of a primer on particulate matter. So you can see our onboarding has changed. It kind of has evolved. I think of these as sort of a storyboard of like how to tell the story of your product before the user has actually started using it and get them excited about using it. And we're always updating it. But we did have to add an additional panel to explain the confidence rating and what the numbers and what the visual design represented. I have placed ease of use as a core attribute, a core pillar of the product. And I think because I control, partly the product roadmap, I can hold that steady. Whereas I do see a lot of times, that can sometimes get compromised when there are other interests at stake. we have been really pushed to add a lot more data onto the screens that I do not think belongs there, because I'm looking for a clean, glanceable, easy to use experience for citizen scientists, but not necessarily people who are scientists. They can be consumers and have a citizen scientist mindset, but I want it to be easy. And I'm not going to budge on that. It's non-negotiable. And so if you look at the design, we did make a change because we had quite a few users asking us. They said, on the sensor list, I want to see the AQI data. I want you to add that to the screen. So we did add it. And here, keep in mind, we're showing that the confidence in the data is being reflected in the translucency. So data that is more suspect or has lower confidence is actually faded. And we're trying to keep the same kind of strong, clear visual design, easy to understand and easy to glance at, because when you're out and about and you look down at your phone, you know, that glance should tell you what you need to know, whether you should go outside or not, whether you should let your elderly parent go outside, or whether you should let your kid go outside to play soccer. You also want to match the interaction model to the user's needs. And what that means is, you know, you may need to blend multiple interaction models like we did. We had to come up with a really good scheme for interacting with geographic data using the mapping interface, and it didn't work when we first launched. You can see that messy, you know, horrible looking map. So we had to go back and we had to fix it and we had to improve it and keep working at it. And that is one interaction model, influenced strongly and controlled by the way the platform is organized, architected in the framework. But you can see when we did the sensor list, we had to kind of think about, like, what's the interaction with the sensors? Is scrolling through a list good enough? No, we have to go back and we have to add filtering, and we have to come up with ways to let users actually control their view of the sensor space when they're looking at it as a list. You know, looking at something in a map and looking at something in a list, two different interaction models. So you have to be able to know what are the attributes that are important to the user. How do you create a good experience for that? And remember, it's all on a mobile device that has to be real time and performant. On the right is looking at the drill down. So you've drilled down into a detailed sensor. How do you represent the data? Now, is the screen perfect? No. Is it constantly changing? We'll keep it changing it, but I wanted to maintain things like clear legibility, clearly understanding and having the confidence that you're seeing the accurate recent data from the sensor. You understand the source of the data, you know, the location, and then you could, if you want, set up your notifications with just a tap. Again, we don't want users to have to do anything when they're on the go, you know, nothing too complicated, no menus or anything. We want it to be very simple. We want to tap to produce a lot of value in the experience. And I think the last thing is to really think about solving for applicable scale. So we saw scale was number of entities. So, you know, maps, geography, lots of, you know, potentially very large geographical area that you're represented in your search space, lists, being able to scroll or filter, and then quality. When you have quality of the data that's really different, how do you represent that? And so in some cases, you know, you have to think like, I want to represent data that's less of which I'm less confident with a different visual presentation. I may have a different color badge, or I may use translucency or something, but that gives the user some more indication of what is the quality of this data? Can I trust it? I also think it's important to understand what attributes of the data impact what I call trustworthiness. So in the case of Local Haze, we said, we want people to understand that this is a confidence badge, but that they can also look at the data in detail. So the precision part of it, looking at the precise part of the data, and then the recency. So these things taken together with the transparency of the location and the source, we're trying to build a sort of larger scale, accurate view to in total produce a more confident perception by the user. We're still working on it, but this has worked out well so far. So when we put it all together, here's Local Haze. there's the scrolling list of all the sensors in real time, drill down, then go to the map, be able to zoom across. It's actually better with it. With each release of iOS, the map behavior gets better. There's Northern California during fire season. There's lots of sensors, not so good air. And then you look and some of the air is quite bad. And you can see that that interaction is quite good. And you know, the real measure is what people say when they use your products. We've had so much excellent feedback. I'm constantly hearing from users. They really love it. People actually, there are some really interesting pieces of feedback. I have a friend who lives in an RV out in the western part of the US, and she said, you know, we use Local Haze as a sort of air quality compass, because we're during the wildfire season, we're trying to figure out where should we go tomorrow or next week. We're looking at the air quality now and where it is in different locations to know where we should go. People have said, I use your app to determine whether or not I should let my kids go outside to play. I use your app to know if it's okay for my elderly parent with COPD to go outside and take a walk. Those are really, really important things for me to hear. And I am always listening. And not everybody loves it. There are complaints. People complain about all kinds of things. But we've seen a lot of spikes in downloads, for example, during events like wildfires. We expect this year the wildfires will start earlier. They usually start around August. We expect to see that earlier. And we're getting feedback from people constantly, both personally, you know, email to me, and then also they post it on the App Store like this one on the right, and really appreciate that, you know, people say that the app helps them in their day-to-day life. It's wonderful to be able to help with that as a designer. So that's the end of my presentation, and I appreciate you listening, and I'll take any questions.